Hello guys, welcome to YouTube channel Your Maths Guide. Guys, on this channel I will complete your class 10 Cbse or NCERT Maths full course. Each and every exercise, each and every sum. Okay guys, so today we are gonna start with exercise 1.3. Third exercise of first chapter, that is real numbers. So guys, what does first question of exercise 1.3 say? Prove that root 5 is irrational. Okay, let us write it down. Prove that root 5 is irrational. Okay. This such kind of sums have to be solved by a method that is called as the contrary method. Means in this method you have to assume that root 5 is rational and then try to prove that it is rational, but it can't be proved as it is rational because we know that it is irrational, and in the end we just have to write, since our assumption is wrong, it is irrational. It is very easy guys. Okay, let us proceed with it. So assume, let us make our assumption. Assume root 5 is rational. Root 5 is rational. Okay, therefore root 5 is equal to a by b such that a comma b are co-primes. Now what do you mean by co-prime guys? Co-primes, co-prime means they have 1 as a common factor. Suppose let us take 5 and 7. So 5 ones are, and 7 ones are. Okay, so these both have, when you remove that prime factors, these both have 1 in them. So such numbers are co-prime. Not co-prime are numbers that have 1 as their common factor. Okay, now we know that root 5 is a by b. So a is equal to root 5 b. You can write it also as a is equal to b root 5. Okay, put this as the equation 1. Now make sure that there's no square. Okay, there shouldn't be any square. So write squaring both sides, we get a square b square and 5. Now whenever you square a root, that is actually 5 to the power 1 by 2 to the whole square. So this 2 gets cancelled, so whatever remains will be 5. Any number that is under root is raised to the power 1 by 2. When you square it, the power totally goes off and just the turn number remains. Okay, then write down, let P a Then use theorem 1.2. Using 1.3, sorry guys, 1.3. What does theorem 1.3 says? If, according to theorem 1.3, if P divides A, okay, if P divides A, sorry, if P divides A square, then P divides A, where A is positive integer. You don't have to write this, guys. I am just telling you so that you understand what is theorem 1.3 actually. Okay, what does this statement mean? After this equation, okay, you are gonna select a number P such that it divides A square. Since it divides A square, it will also divide A. Okay. This. Now, next step. After this, since A square is divisible by 5, therefore A is divisible by 5. Okay. Now, here equation 2. Therefore, A is equal to 5C. Okay, guys. See, this is because is why, from where did this C come? Okay, it is as, let's say A's value is 40. Okay, so 40 into 5, 40 is equal to 5 into 8. So whenever, if A is some value, whenever it's divided by 5, it should be multiplied with some value. So we are taking this here a number, any number, where C can be any number. Any number. Okay. So take this as our equation 3. Now substitute equation 1 in 3. So what is equation 1? A is equal to B root 5. So A will be 5C. Correct? A is equal to B root 5. So B root 5 is equal to 5C. Now I've told you there shouldn't be square, there shouldn't be any root, so square both sides to remove the root. So this will become B square to 5 is equal to 25 C square. Okay, so this will be 5B square is equal to 25 C square. So 5 ones are 5 5s are. So B square is equal to 5C square. Now again, b square is divisible by 5. Therefore, b is divisible by 5. Correct? So, this will be our equation 4. Therefore, by 2 and 4. See guys, we have 2. Second statement is what? Since a is divisible by 5, okay, and b is divisible by 5, they both are divisible by 5. By 2 and 4, we know that a and b are divisible by 5. Divisible by 5. Therefore, a and b are not coprimes. Right? We have taken our assumption that root 5 is rational and a and b are coprimes. But here, with this, we have proved that a and b are not coprimes. Okay? So, therefore, the assumption, therefore, this is contrary to the assumption made. Therefore, root 5 is irrational. Again guys, even in this sum, such statements are very important to be written. Without these statements, you won't be getting full marks. So please make sure that you write such statements. Okay guys? So now, let us move on to second question of exercise 1.3. What does second question of exercise 1.3 say? Prove that 3 plus 2 root 5 is irrational. Okay guys, this is the easiest way. This is the easiest method, because we already know that root 5 is irrational. We have already proved it. So in this, we just have to say that we already know root 5 is rational and prove this sum is irrational. This number is irrational. So again, do the same assumption guys. Assume 3 plus 2 root 5 is irrational. Okay. Therefore, 3 plus 2 root 5 is equal to a by b. Here, a comma b are not coprimes. Here a comma b are not coprimes guys. Okay. Whenever there is a plus in such sums or more two terms, that time you don't have to take coprimes. A and b are just positive numbers. Okay. So guys, now therefore in this, send this 3 over there. 2 root 5 is equal to a by b minus 3. So now here we will have to take LCM. What will be the LCM of this? 2 root 5 is equal to a minus 3b by b. So now just for root 5, we need to send this 2 over here. Okay. Root 5 is equal to a minus 3b by 2b. Here we can see root 5 is equal to a minus 3b by 2b. Correct? Therefore a minus 3b by 2b is rational. Right? Because it is in the form a by b. So a minus 3b by 2b is rational. Therefore root 5 is rational. But we know that root 5 is irrational. But we know that root 5 is irrational. How do we know that? From our previous problem. But we know that root 5 is irrational. Hence this contradicts our assumption. Okay. Hence proved root 5 is irrational. See, this is very easy. You just have to write 3 plus 2 root 5 equal to a by b. Send this 3 on the other side. Take the LCM. Send this 2 on the other side. And just write few statements. It is as easy as that. Okay. So now let us move on to our third question. Third question. First, 1 by root 2. Yes. Again the same way. Here also assume 1 by root 2 is rational. Let 1 by root 2 is equal to a by b. Okay, where a comma b are coprime. Now what happens is, see, therefore 1 by root 2 is a by b, therefore root 2 will be b by a. Correct? 1 by root 2 is a by b, therefore only root 2 by 1 will be b by a. Correct? So since this 1 is in denominator, we don't have to write it anymore, so we'll just keep it as root 2 is equal to b by a. See here guys, b by a is rational. Here b by a is rational. Therefore root 2 is rational. But we know that root 2 is irrational. Right? Therefore this is contradictory. this is contradictory to our assumption. Over. Hence proved 1 by root 2 is irrational. See, these sums are very easy, like literally very easy. You don't have to worry about anything. So let's go to our second question. Third mean second question. 7 root 5. Again, the same thing is we have to assume it as rational initially. So assume 7 root 5 as rational. Okay. So since we have assumed 7 root 5 as rational, let 7 root 5 is equal to a by b. So what will root 5 be equal to? Therefore, root 5 will be equal to a by 7b. Here we can see a by 7b is rational. Why it is rational? Because it is already in the form of a by b, right? So therefore root 5 is rational because root 5 is equal to a by 7b. So root 5 is rational. Okay, but again same thing, we know irrational. But we already know that root 5 is irrational, right? This contradicts our assumption. This contradicts our assumption. Therefore, root 5, 7 root 5 is rational. Okay, guys. So now our last sum. Third mean third sum. Third sum. 6 plus root 2. Again the same thing, guys. Assume 6 plus root 2 equals 6 plus root 2 is rational. Let 6 plus root 2 be equal to, let 6 plus root 2 be equal to a by b. So now again 6 plus root 2 is equal to a by b. Root 2 is equal to a by b minus 6. So again here LCM, root 2 is equal to a minus 6b by b. Here we can see a minus 6b by b is in the form of a by b, right? Therefore a minus 6b by b is rational. Therefore root 2 is rational. But we know root 2 is irrational, right? We know that root 2 is irrational. This contradicts our assumption. This contradicts our assumption. right? This contradicts our assumption. Therefore, proved 6 plus root 2 is irrational. That is it, guys. These sums are very easy. You just have to like understand the concept of contradictory. You have to prove it is contradictory and then prove the question. Okay guys, if you have any doubts you can ask me in the comment section below, right? And make sure to share this video and like it. Also make sure to follow this YouTube channel, Your Maths Guide, for the complete class 10 CBSE math syllabus. Guys, thank you guys.